Okay, so dear students, so we are going to continue with what we were doing in our last class, and we were doing a new chapter. We have started a new chapter called motion in a straight line, which was also known as rectilinear rectilinear motion. And we have also uh, talked about kinematics. That is, so kinematics is a branch of physics that deals with the motion of an object without dealing with the cause of the force or cause of the motion, or without bothering about the force that caused the motion. So that's kinematics. And we also discuss position, and what we discussed under position was a particle or an object position can be um, can be recognized or can be okay, given by three coordinate system. So one was one dimensional, 1D. Second was 2D, and third was 3D. This was physical x, here xy, here x, y, and z. So this was one dimensional system, this is two dimensional system, and this is three dimensional system. Now in this particular chapter we deal with rectilinear motion only, that is motion in a straight line only. So in plane, like in 2D or in 3D, you can have curves like this, or like this, or anything, any curves of any shapes. In 2D you can make curves, in 3D you can make curves, but in 1D you don't have a choice to make curve. That means in one dimension only one type of motion is possible, that is straight line motion. For example, this motion, or whatever, this motion, because you cannot make curves in straight line, because curves are basically a planar figure which needs two coordinates, but a straight line needs more or less one coordinate to specify itself. That's why in rectilinear motion we will deal with only one dimensional motion. So this is basically rectilinear motion or one dimensional motion. Okay, so I just want to justify why we cannot why a curve is also possible in two dimension. See, suppose we have a particle, and if this particle can move from this point to this point, see, particle can move from this point to this point, then what will happen? Then since this particle, let us see, this particle has initial x coordinate as x dash and final x coordinate as y dash, let us take, and when it moves to this point, its x changes as x and its y changes to y. That means its y coordinate also changed, is its x coordinates also changed. That means it's both x and y coordinates change. So that means it's both two coordinates are changing. That's why it is known as two-dimensional figure or two-dimensional motion of this point. So in basically in curves or in two dimensions, both coordinates changes. But in one dimension, what will happen? See, suppose you have only one coordinate. That means initially the particle was here at x position, and finally it will move to another position, x dash. Now see, it has only x coordinate because this is only one dimensional. So its x coordinate changes to x dash. It do not have any two coordinates. That's why the particle moved in a straight line. So here the possibility was the particle can move from here to here in curve also, because from if a particle moves from one point to another point in a curve, then it's both x and y changes. Its x also changes, its y also changes, because a point on the curve has both x and y coordinates, but a point in a straight line have only one coordinate in one dimension. That's why rectangular motion are basically one dimensional motion. So next topic will be displacement. So displacement. So displacement is basically the difference of the final and initial positions of the object. So this displacement is basically the difference of the final and initial position of the object. So for example, if you have an object, okay, before displacement I want to discuss path length. Path length. So path length is the total distance covered by an object in its course of motion. So path length is basically the total distance covered by an object in its course of motion. For example, you have, so this is positive, this is negative side. Suppose you have an object here at this position. Suppose it moves to this position. So it was at origin. So it moves to point P and it return back to point Q. Point Q. Then what is the total distance traveled? Total distance traveled. Distance traveled. So total distance traveled is from, suppose these are in centimeters. So from 0 to 3, it was 3 centimeter. Plus it came back to 3 to 1. That means it traveled one more 2 centimeters from here to here. That means 2 centimeter. That is 5 centimeter is the total distance traveled if it moves from 0 to 3 and 3 to back to 1. So this is the total distance traveled is 5 centimeter, and this 5 centimeter is known as path length. So path length is the value of the distance traveled by an object when it moves from one point to another point. For example, again I want to give one more example. This is origin, this is 1, this is 2, this is 3, 4, this is minus 1, this is minus 2, this is minus 3, this is minus 4. Suppose the object was at this point, origin. Suppose it moves to point P, and from P move back to point Q here at point 3. Then what is the total distance covered, or what is the path length in this case? So path length will be equals to, firstly it moves from 0 to 3, that means 3 centimeter. Now when it came back from 3 to 3, it traveled, see, 1 centimeter, 2 centimeter, 3 centimeter, 4 centimeter, 5 centimeter, 6 centimeter. So from here to here it traveled a distance of 6 centimeter, that means 9 centimeter. So in this case the path length is 9 centimeter. But what is displacement is? A displacement is the difference of the final and the initial position of the object. For example, this is origin, this is 1, this is 2, this is 3, this is 4, this is minus 1, this is minus 2, this is minus 3, this is minus 4. Suppose the object was at this point P or origin O, and suppose it moves to position P P. Then what is its displacement? Its displacement is the difference of the final and initial positions of the object. So final position of the object is 4. The object is at 4. So final is 4 centimeter minus initial was 0 centimeter. So it is 4. Another example of the displacement is, okay, I draw a coordinate 0, 1, 2, 3, 4, minus 1, minus 2, minus 3. Suppose the object was at 1 initially, O. From O it moves to P. So what is displacement? Displacement is, the formula of the displacement is final position, that is xf minus xi. xf is the final position at x-axis, xi is the initial position at x-axis. Suppose these are in centimeters, this way. So final position at x-axis is 3. So it is 3 minus initial position at x-axis was 1, because it moved from initial to final this way. So 3 minus 1, that is 2 centimeters. So the object got displaced to 2 centimeters. Suppose it moved back from, okay, another example is, okay, suppose the object moved from O to Q directly. Suppose the object moved from O to Q directly, from 1 to 4, then it came back to this point 2, that is OQR. So what is happening here? Suppose I have an object at point O, then it moved back to Q, and from there it moved back to position R. So its motion is like this, from here to here and here to here. So what is displacement in that course? So in that course displacement will be, so you need to see only the initial and final position. So displacement will be final position minus initial position. So initial position was O, then it moved back to Q, and finally it reached to R. That means final position is R. Its initial position was O. That means its final position is R, that is 2 centimeter, minus its only initial position was O, that is 1 centimeter. That means its displacement is 2 minus 1, that is 1, or 1 centimeter. So it moved from minus 1 to minus 2 this way, from here to here, from P to Q. So it was at P initially, it moved to Q. And what is its displacement? So the same formula, the displacement will be x final minus x initial. So x final was minus 3, x initial was minus 1. Minus, see, x final was minus 3, x initial was minus 1. That means final position it was at minus 3, initial position it was at minus 1. That means minus 3 minus initial position is minus 1. So this is the initial position minus 1, it is the final position minus 3, and this minus is this. So you have 3 minus sign here. So once again, final position is minus 3, initial position is minus 1, and the minus is the minus of the formula. So what is the answer? Minus 3 plus 1, it is minus 2. So displacement is minus 2. So I want to give you some homeworks related to path length and displacement. So homework. So calculate the path length and displacement in the following course of the motion. Suppose this is your 0, this is 1, this is 2, this is 3, this is 4, this is minus 1, this is minus 2, this is minus 3, this is minus 4. Suppose the object was at 0 initially, it moved back to point 3, that is P. Again it moved back to from P to Q, and from to Q it moved back to OPQ R, this one. So initially it was O, it moved to P, from P it moved to Q, from Q it moved to R. So what is the path length? What is the displacement? So this you need to calculate. I was in hurry little bit today, so I didn't. Uh, I think I like didn't explain you very clearly, but the way you understood, in that way you have to answer this particular question. So find the path length and displacement in this course of motion. Thank you for today.